All right, let's get started. Good evening, or good afternoon, good evening, everyone. This is the last session of the day. My name is Dagdag. Today I will be talking about making neural network run in browser with ONNX. My name is Dagdag. I'm a director of software engineering at Spacey. I'm based in Texas, and I'm also a Microsoft MVP, an AI MVP. All right. If you are a Pokemon fan, I'm sorry, I'm not going to be talking about the Pokemon ONNX over there. So, and also, I heard that also in Australia, they also have the ONNX mineral, also they're mined here. I'm not going to be talking about that. We're going to be talking about ONNX. What is ONNX? We'll talk more about when you should use this. But let's go back to the basics and talk about what is programming. Typically, when you're programming, right, you have an input, then you create and write an algorithm. Like, for example, in Java or in Python, you would create your code. And like in this case, we're creating a calculator, and then it would spit out answers, right? It would generate the answers for you with those two inputs. For machine learning, it's like the other way around. The goal is to be able to teach the computer to create an algorithm for you, and it needs lots and lots and lots of examples or answers. So you need both, input and then answers. And then it would generate an algorithm for you, right? And you'll see that, if you're in the previous presentation, a lot of the AI and machine learning topics, they do this, right? You have to have a bunch of images. You have to tag those images in order to create like a custom vision or computer vision language. So as an ML primer, programming is on the right side, machine learning on the left side, okay? In machine learning world, that's what we call training data. And you need a training framework in order to create a model, to generate a model, and that's what you would use and substitute with that algorithm. And in order to use that model, you would need, in machine learning, we call that inferencing. And then you need an inferencing runtime in order to complete the cycle. And of course, now that you have all the answers, and it's a feedback loop to improve the model. When I first saw this concept, suddenly it started to make sense to me what everyone's talking about, what's the power of this machine learning. And we'll talk more about this, but we'll go back to where we create this model, okay? So typically, if you are a data scientist, and a lot of data scientists these days, they talk about, they know a lot of Python, and they would use their favorite machine learning framework. In this case, let's say they're trained using PyTorch, and they run it locally on their device, on their machine, right? But I found out if you're a JavaScript developer, there's a lot of JavaScript framework. The same way in machine learning, there's also a lot of machine learning framework that is available out there. One of the most common ones are, of course, TensorFlow and Keras. And of course, PyTorch is one of the most, that's a lot of, notice a lot of them coming out of school, they are used to that. And of course, you have different places where you would execute these models, right? Or your program. We're not just limited to laptops anymore. We have to run it on phones. We have to run it on IoT devices. We run it on the cloud. Different ways in how you would run these models. And that's what ONNX solve. think about ONNX is kind of like how the PDF works, right? You create, let's say, Microsoft Word, type your document, you export it to a PDF, and now you have different places where you can view that document. You can view it on Kindle, accept those PDF, browser, on the phone, everywhere else. So think of it that way. So ONNX is Open Neural Network Exchange. It's an open format for machine learning models. It is open source it's on GitHub, github.com/ONNX. And best place to learn about these is going through ONNX.ai. It got started with partnership with Microsoft and Facebook, but through time, more and more, every time I would do a presentation about this, one more company signs up on this list. And notice that they're not limited to software, but also hardware companies are supporting the ONNX format. Of course, it's on GitHub. It has about 2.7 GitHub forks, 12,000 GitHub stars. It is actually a graduate of the Linux Foundation AI project. So it is ready for production use. So when should you use the ONNX format? Well, if you have something, like we said, you have data scientists, they know Python, or someone that has .NET experience, have used ML.NET, and now you want to integrate it with your existing C# application or Java application or JavaScript application. That's when it makes sense to convert it to ONNX and then integrate it with that existing application. A lot of data scientists in my company, they know a lot of PyTorch, and containerizing a PyTorch model, a Docker image, it is actually about almost 4 gig already. Imagine if you have to do deployment and the framework itself incorporating that every time in order to run your application. I mean, that's not going to fit very well on smaller devices. So you also want to use ONNX when you need a high inferencing latency. That means you really need fast results for production use. That means you're running it specifically for that machine or that device, and you running it locally instead of the cloud. When you have a model that you want to run on an IoT or edge devices, so the Azure Percept device is a good example. It uses ONNX in order to run their models. And if you want to run it on a different operating system or hardware, that would be a good use case. So it's not just limited to Windows machine. You can run this on Windows, also on Linux. Different hardware too. So not just AMD, but also or Intel chip, but also ARM processors as possible to do this. There's also a way you can combine different models. Let's say in a big company, you have models that were generated in Keras, and then you have also models that are generated in PyTorch. And now you want to create a pipeline where you run inferencing from the other, or that allows you to be able to have just one place where you can run these. And then there's also transformer models where you can have training locally instead of sending it remotely. So our agenda today, we talked about what is ONNX, and then the next step is how do we create this ONNX model and how do we deploy them to deploy these devices. So this is a good summary of what we're going to do, right? So we create the framework. We we convert it to ONNX model, and now you can deploy it not just on the Windows devices, IoT edge devices, and all that. So I started talking about ONNX model. There is a way you can visualize once you convert an ONNX model, and there is an open source application called netron.app, or even if you go to netron.app and you drop an ONNX model, it actually visualizes what is the input and output of that model. Let's see if we can do that real quick. Yeah, we'll go back to this once I continue on with the demo. So first, we're going to create the model. How do we create them? Okay, so backstory. When the pandemic got started, and bread is kind of limited in our neighborhood. You can't just easily buy bread. We started using our bread maker. It's our first time to use our bread maker. It was a wedding gift for us, but we didn't use it because it's just easy to buy bread. And we found out, okay, let's make some bread. But our first try didn't work. We didn't know the secret recipe. I guess we found out that you have to use warm water instead of like cold water, and we used cold water. It didn't turn out right. So what I'm trying to say here is that the data scientists in your company, they're the ones responsible to figure out what's the secret recipe of your company, right? They experiment and try out different ways on how you would create this model so that, so what it would be the most effective use for that data. So 3 ways on how you would create that ONNX model, right? One is through the ONNX model zoo, the custom vision service, and then converting existing models. Let's start with how you would create the model zoo. On GitHub, if you go to this link, a lot of existing models that are out there, so especially on image classification, they already did convert from, let's say, however it's trained, let's say in PyTorch, they converted it to ONNX already, and it's free to download. So if you just want to reference a model that is available out there, check out here first, right? Maybe they already have it available for you. So let's say if you're, one of the popular ones are the ResNet device, ResNet model. It's already converted, and you can just download that. Another one is through custom vision service, where you can upload. So if you go to customvision.ai, you can upload some images and tag them. Like in this case, I uploaded images of fruits, and I tag them, hey, these images are fruit. And then I can click train, and it would create a model for me. And then you can actually export it to an ONNX model. There's also SDK, so you can automate this process of uploading to custom vision, training it, and then exporting it to an ONNX model. Converting models is also another way. There's 3 steps involved in order to do this. You load an existing model, then convert it to ONNX, then save that ONNX model, okay? So PyTorch, it looks something like this. This is the simplest one I can find, and if you're not a Python developer, that's fine. My point here is that there is a library called torch.onnx, and you just say torch.onnx.export, you specify the model, the sound output, and then you're good to go. In this case, this is a sample model that they have available out there, but there's already bindings for PyTorch to do this. For Keras, the same way too. There is a way you can convert them using these ONNX ML tools. So you would do pip install ONNX ML tools, and it already have that capability for you. So it's not just code, there's also command line that you can use, especially for the TensorFlow. You can convert it using this. So I just have it as a reference just in case you need to visit it later on. The best way to learn more about how you would learn how to convert from existing models is using the tutorials on ONNX in GitHub. Okay, the typical end-to-end process of how you would create these models is, how you would, either you have it in Jupyter Code or maybe you have it in Azure Machine Learning, right? And you train it. The advantage of Azure Machine Learning, there's a way that you can register, and this is the key part of it, right? Register and manage your model. So it's kind of like GitHub. Think about code, right? Git is, you have a repository of the changes in your code. Every time you train a new model, it's the same concept too. That's, at the end of the day, those are algorithms. You want to be able to do, you have it in a repository, and that's where you have that management and where you can register this model so that now you can be integrated with your application. Any questions so far? Because I know I'm talking about these. Is it good? All right, so now that we're able to create a model, the next step is to deploy. But before I do that, I wanted to do a little bit of demo on how you would do this in ML.NET, okay? Since we have enough time. So what I'm using here is I'm using Visual Studio Code, and on Visual Studio Code, I'm using .NET Interactive. And .NET Interactive allows you to be able to have a Python notebook that has, instead of using Python, it's using C# as your kernel. So in this case, so I can show you line by line what happens when we run this application. Okay. So these are the NuGet packages. If you're using it in ML.NET, these are NuGet packages that you can use, that you can incorporate to your application. So it's kind of like a node package. And then these are just the some using statements or reference for the code. In this case, I'm loading a CSV file, and this is my CSV file, and this is what it looks like. I have 2 columns on that CSV file, input and output, years experience, and then salary. Just the simplest thing I can find out there that doesn't, it's contrived, but you have 1 input and 1 output. So if I put data.description, it tells me I have 30 items on that list, and what is the min and max, the values on there. And in this case, what I'm doing is I'm going to use ML.NET in order to create a model for me. So in order to use that, I have to create this new ML context, and then I create a pipeline, I specify what is the trainer, how am I going to create this model, and then train it, okay, and then evaluate, okay. So my point here is not necessarily, not learning how to train. My point here is I wanted to show you that you can export the model to ONNX using this command. So once you have the model generated, you have to pass 3 things, right? You pass the model that was generated by ML.NET, and then you create the stream, and then you would export it. And if you open the file in ONNX Netron app, it would look something like this. So it generated, notice how it generated this model.ONNX. So once it generated that model.ONNX, I installed this Netron app, and it would look something like this. It's kind of harder to see why it looks like that, but usually it visualize it right. But my point here is that it tells you what is the input for that model, and it tells you what's the output of that model. So this would help developers, software engineers, if they want to integrate, once they convert it to ONNX, what is the input and output without going going back to the developer, to the data scientist, and then we'll have that information. In this case, this is a simple model. It's not even neural network. It was a regression, and it has years in experience as input and salary. And then what we're interested in here is the score, that output, which gives us the result of what it predicted that it needs to be. Okay. So that is just an example of how you would do this in using ML.NET. So now, how do we deploy them? What is the difference between a baker and starting a bakery? Totally different skill set, right? Like was said, bakers, they figure out the secret recipe in order to have a good bakery. I come from a software engineering background. We know how to start the bakery. That is our expertise. Right? If you think about how we put things together and create a pipeline for our application, we know how to collect the money. We know how to pass the data from one place to the other, to process the data, to create those business rules in order to, think about how a baker can be the best baker in the world, but if they can't collect the money, if they can't, you get what I'm saying? If they don't have a system, then they can't deliver it right. And that's the main difference, right? So deployment is very important whenever we create these models and how to integrate it with our application. Like going back here, where you specify and register and manage the model, now we can, if we're running it in the cloud, we can build an image where we integrate whatever that model is and deploy it as a service. So this is one way on how you would do it in cloud settings. But in this case, every time we have to work with these models, we have to decide, are we going to run it in the cloud or are we going to run it at the edge? Meaning the inferencing side, right? So a lot of examples out there, whenever they, for example, a lot of the cognitive services or the pre-trained AI that's available out there, you need an API key, you upload these images, you upload the sound, and then it would give you the results. So that's pretty much running it in the cloud. But there's also advantages of running it at the edge. If you think about it, the good example of this is McDonald's versus Subway. And where do they make the bread, right? How close it is to the customer. So they can be flexible. Subway can be flexible because they make the bread at the store versus McDonald's, they source the bread in a factory somewhere else. So that's the main difference between the two. Of course, what is the edge? I have this image because whenever you're deploying these models, right? So we have these ONNX models. Now you have to think, if it's in the cloud, oh, sorry. Where am I at? Okay, if it's in the cloud, it did way, you're deploying to maybe, different data centers, right? There's also a concept of fog or node computing. So when you think about 5G and how what it means is that your processing happens on the tower instead of back where Azure is or a data center. So it is closer to the user. But now if you're deploying models or you're deploying this code, now you have to think about millions of devices as compared to edge devices. If you're running it on the browser or you're running it on your phones, now you're talking about billions of devices. So we just do a good visualization of when you're running your application, you're running your models, there are different considerations where you would run them. So ONNX Runtime is a high-performance inference engine for ONNX model. It is actually started by, and it is open source, by Microsoft under MIT license. It's fully compatible with ONNX ML spec. It's actually part of Windows 10 if you're a Windows developer. But ONNX Runtime.ai allows you to be able to select, like in this case, I have a Linux, I'm running it on a Linux device, I want to run it on C#, and with that architecture, and I want to use the GPU, it gives you instructions on how you would run these models and incorporate it to your application. In this case, we're going to be talking about this side right here where you have the web browser. So it's not just limited to what platform it is, it's also, ONNX model can run on the browser, iOS, Android, Mac, and also different APIs. So ONNX Runtime is available for JavaScript, and there is a Node.js binding. Also, you can run it on the web, and also if you want to integrate it to your application, you can use React Native to do that. So let's start with ONNX Runtime using Node.js. It is for ONNX model inferencing. You can actually incorporate it to an Electron app, and it uses WebAssembly. In order to install it using Node, npm install ONNX Runtime Node, and you can use CommonJS in order to incorporate it to your application. So I'm going to show you a little bit of demo of what that looks like. Okay. Yeah, feel free to ask questions if you have. So this is using Node. I have this dependency. I did npm install ONNX Runtime Node. Can you all see that? It's good. So that is the latest version. So I have this ONNX, model ONNX, right? And this is how you would use it. So in this case, there's three important things you have to consider when you're running it, right? You have your importing, right? You have your ONNX Runtime Node, and you specify, okay, now I'm going to load the ONNX model into memory, and then I have to pass the input. And in order to pass the input, in this case, right, for my ONNX model, I need 2 input, because that's what it said on the Netron app. And the input is years of experience, and then salary. Even though it's not being used, it is required, so that's the reason why I have that there. And so this is a good visualization of how I know it's not being used. And for this simple example, I have years of experience. The data would get processed here, and we know that the score output is what we actually need. And the rest of them, they're just passed through and not being calculated. Okay? So now once I pass in my data, in this case, I'm going to put 15. Right, that is my input, and how I know it's one-dimensional array is what I need, is because in this ONNX model it's specified -1, 1. That means it's -1. Usually it's a tensor, and it does not need. It only needs one-dimensional array because it's -1 it gets ignored. It's just one line. Okay. Like in this case, and then I pass in salary 0 because it's going to get ignored. and then you use this ORT tensor in order to create the feed, and then that's what you pass to your session. And once you have the session, it will give you the result. So let's see if I can run this application. And so that's what it returned to me. I pass in an input, and then it gave me an output, and I know the output data that I need is using the score.output binding, and then it returned the data. Any questions so far?
Is this available?
Yes, I have it on GitHub, and I'll give you the link. Yes. So my goal here is to find the simplest way on how we can give that example so you can reference it later on in case you need to. So that's how you would incorporate a node, right? I created, think about what happened. I created a model using ML.NET. I exported it to ONNX, and now I'm using it in my JavaScript application. Okay, let's go back to the presentation.
And just a question about the running models on device like JavaScript. Are there like performance impacts to be on JavaScript? I mean, is it when you run the model, is it slow or you get a response really quickly?
It's actually faster because it's, so for JavaScript, because it's running using WebAssembly and also WebGL, it runs it, and if GPU is available, it would automatically allows it to happen. Of course, it's lightweight model, and in this case, you're running it on the server. I'm running it on my machine, so it depends on the capability of that machine. Yeah, it's not really real JavaScript, right?
Your demo is running on the server side, right?
Yeah, this is, since it's a node application, it's on the server side. Yeah, it's not yet in the browser.
But there's a client side.
That's what I'm going to be talking next. This is the client side of things, right? So in this case, this is a JavaScript library running ONNX model on the browser itself. And it's using WebAssembly and WebGL technologies, and it can both run in CPU or GPU. One interesting I found today, there is also a React template. So if you are a React developer, and if you want to incorporate it into your React application, there is a template that developer can start using. The key to it is, you have this npm install, right? ONNX runtime web, and then you import it to your application here. Let me show you a little bit of example on that. So why would you want to do this? Well, it's faster. You were asking about performance. It is faster because it's running in the browser itself. So there's less communication to the server. So let's say if it's an image and you're doing image processing on the browser itself, that makes it faster. It's safer because you're not sending data outside of that of the network or the machine itself. It also works offline because once it has a copy of the model running in the browser, then it does not need to send anywhere. And it's way cheaper too because you're using the device itself rather than borrowing other people's computer, which is the cloud, right? So when should you not use or run it in the browser? Well, when the model is too large. There's instances that it requires higher hardware specs. The company where I work for, we do a lot of image processing or object detection, and some of the models can get large, 200 megabytes. And if you think about if you have to download 200 megabytes to your device, that would kill the experience. So you have to think about simplifying that model, or maybe it makes sense to pre-process or post-process that rather than on the device itself. So let's look at a quick demo how we would do this. Okay, so this one right here, I have on my package JSON. There's no dependency because I'm not running it in Node. Let me run this first because it makes sense to showcase it before I talk about the code. So in this case, I'm going to run it in the browser. And localhost, it's running it locally here. It says 8081. Okay, so this is website. What I'm going to do is I'm going to pass in an image, and it would scale and change that image, and it would give me the result. So the simplest way I can think of, and this one right here is using a different ONNX model. In this case, I downloaded it from the ONNX model zoo, and it is available out there. And it's called this emotion for -8. So it detects emotion. So looking at this code, if you look at the index.html, I reference this script, which is on a CDN, which is the ONNX runtime web ORT. That is shortcut for it. So this ONNX runtime web, and this is pretty much the website to upload the image and do its processing. But the key point here is on this main.js. This main.js, when it receives an image, okay, and once it starts processing that image, it would load it. And once I load that image, I would handle it and convert it to a tensor in order to, because the model needs it at a certain size. So I need to resize that model, change it to pretty much would look something like this. So I have to grayscale it, and it had to be a certain number of pixels in order to pass it properly. If I go to, let's see if I can view this, emotion ONNX file. Let me see if it'll open it for you. Come on. Netron. See, this is, the graph of the instruction set. So the input would come here, and it processes it all the way at the bottom until it gives you the result. This ONNX model, it needs one input that is 1,1,1,64 by 64. So what it tells me is it needs an image of 1 bit 64 by 64 in size. And that's the requirement in order to pass this value. And it would give me an output, which is a tensor of 1,8. So it's a one-dimensional array of 8 items in it, okay? So that helped me identify what I need to do in order to run this application. So I process this image, I resize it to 64 by 64, and processing the image, this one, I scale it to a certain size, and then based from that, I convert it to grayscale. Once I converted it to grayscale, then I have to convert it to this tensor, right, of that image. And this tensor, it requires me to use this ort.tensor. I specify, the value on each one of those pixels. I have to pass that in. And once I add it to this ORT.tensor, then I can pass it to my ONNX runtime. So the meat here is this. So I would use ORT.inference_session.create. I have this ONNX model that I loaded in a session. So there's always 3 steps. You load it into memory, and then you pass, and you create your input. Like in this case, I know it needs input 3. How do I know this input 3? Is because the ONNX model told me I need to pass that as a parameter. And I have the tensor, and then pass that using session.run, and it will give me the result. In this case, I know that this output would receive, it's either going to be neutral, happiness, surprise, sadness, anger, disgust. That's what it would give me the results on, and then I get the maximum value, whichever is the highest out of that list, and then I can display it properly. Okay? Can we reuse? Yeah, you can reuse that session once you loaded it in memory. In this case, since this is the simplest example I can find, I can just load it as go. Yeah, definitely. Okay. So React Native allows you to score a pre-trained model. This is a little bit advanced, but if you want to run it on Android or iOS, it allows you to do this also. But in order to do that, you have to convert the ONNX model to another model that is optimized for mobile. And they call it mobile.ort. And then that's how you would, it minimized the binary size because it really needs to be able to have more optimization for running it in the browser, because browsers have, of course, better memory as compared to the constraint on your phone. So that's the reason why it had to be optimized specifically for what you're trying to deploy it on. So compatibility-wise, it works with, if you're going to run this in the browser, it works with Windows 10, Mac OS, Ubuntu, iOS, Android, right? Runs in Chrome, it runs on Edge, on Safari. You can use it for Electron because it's node binding, and Node.js. So for Node.js, it's using WebAssembly, but for the browser, it's either you're going to use WebAssembly or WebGL. And it feels like this after talking about these technologies, right? So just to recap what we've done so far, we did talk about what is ONNX. It's an open standard. It's the right tool for the right job, right? If your application is already in JavaScript, you have a web application, use ONNX and ONNX runtime in order to integrate it with your target platform. How do you create an ONNX model? Models can be created. I did show you different frameworks and how you would create the ONNX model. I did a demo on using ML.NET and also some code using Python. How would you deploy it? You can deploy it not just in JavaScript, which I did demo today. There's a way you can integrate it with your .NET application or Python. You can also use Windows ML in order to do this. And of course, if you're going to run it in the cloud, you can use Azure Machine Learning with using ONNX runtime. If there's anything else that I want you to remember about this talk, it's this, right? Once you started looking at it at this point of view, you're going to understand when is the best use case of when should you have a different pipeline for inferencing versus the different pipeline for training the model. All right, if you're interested in learning more of the demo today, I have it on my GitHub, and you can connect to there. Oh, one thing. You see those glasses right there? These are spectacles, which is from Snapchat. Snapchat is one of the partners that are actually using ONNX. And one way to run machine learning on those glasses is converting it to an ONNX model. And I did try that, and I was so happy. It's like, oh, that's cool. It has object detection, it has segmentation, and all that. So if you're interested in learning more about me, my name is Ron Dagdag. I'm a Microsoft MVP. The best way to contact me is through LinkedIn and Twitter. And I appreciate you geeking out with me about bread, about ONNX, and glasses. Thank you very much. Appreciate it. Yeah. Any questions? I know it's a big topic. There's a lot of examples that I did demo. And this would, feel free to ask any questions if you have it.
So is ONNX becoming like the standard in machine learning, or some data scientists will say, no, we prefer to use something else?
Well, if you're using PyTorch, right, and then of course, you have a choice, right? How do you incorporate it to your application? Of course, you can use PyTorch in the cloud side. But now if you're going to run it at the edge, then it makes sense to convert it to ONNX, right? TensorFlow, there's TensorFlow.js. So if you have it in Keras, it allows you to run it using TensorFlow.js. And if you have developers that are that they did their models using Keras, you can actually convert it to ONNX. Or let's say you have a developer that's using PyTorch. They created the model using PyTorch, and then then you wanted to run it using TensorFlow.js. You can use ONNX to convert it to Keras also. So ONNX is kind of like a middle ground to convert from one place to the other, and also a way to optimize. Of course, there's limitations, and because sometimes there might be a need to create a custom operators. Because at the end of the day, they're trying to map instructions, right, to make it portable. Just like the same way as JVM when they first started, you're converting it to like a intermediate, the machine library and all that. So they're converting from one for the operators from one language to the other, and have different implementations specifically for that. So sometimes they don't have a match, or they haven't mapped it yet. So that requires some extra work that you need to do. But for the most part, what I've seen so far is, if your backbone of the model that you create, especially in custom vision or for computer vision, if the backbone can convert to ONNX, most likely the custom models that gets created can be converted properly. Yeah.
So I want to know your sort of like thought process when you try to architect a solution around IoT and machine learning and etc. When do you choose between dumb device versus smart device? When do you make a decision to we probably need some edge analytics deployed close to the device, or we just have a central hub where you stream the data to and do processing in the open cloud? So what is the
what would be the best
criteria?
approach? Yeah. Well, cost, right? Right. One of the best criteria is, if you're sending a bunch of these data for processing, if you're sending images, that can get expensive, right? Or think about sound. How these Alexa devices or these Google Home devices, right? The wake word is actually running on the device itself. Whenever you say, "Hey Google," or it knows, it understands that. But anything after that, it gets sent to the cloud for processing because they have a bigger model. So in terms of IoT, those are the things you have to think about whenever you're deploying some of these applications. So for example, if it's related to computer vision and you're doing some object detection, it makes sense to run it closer to the edge rather than in the cloud because you want that processing happens locally rather than sending it in the cloud. So those are the things you have to consider. And then what you're sending to your event hub or sending to your stream are just the results of the inferencing rather than the, the whole raw data itself. So that helps. Cool. All right. Appreciate your time.